Let us look at the second step of solving linear programming problems using Simplex method. The second step is known as standardization of the problem. Now this is the linear programming model that we had arrived at in step number 1. So we have to maximize p equals to 10x1 plus 4x2 subject to the constraints 20x1 plus 10x2 is less than equal to 1200, 40x1 plus 10x2 is less than equal to 1600, and x1 and x2 are greater than or equal to 0. Now as you can see, these constraints have these inequalities less than equal to. Now in order to solve these LP model using the Simplex method, we need to convert the constraint inequalities into equations. That means we need to convert this into equal sign. So what that means is we have to make the left hand side equal to the right hand side for both these constraints. Now let us consider the first constraint, which is 20x1 plus 10x2 is less than or equal to 1200. Now just to remind you, x1 is the quantity of gear type A to be produced and x2 is the quantity of gear type B to be produced. And 20 minutes is the time taken by gear of type A in the blanking shop, and 10 minutes is the time taken by each gear of type B in the blanking shop, and 1200 is the maximum time available for production in the blanking shop. Now what this constraint means is that the total time taken by gears of type A and type B in the blanking shop is less than or equal to 1200 minutes per week. So basically this can either be equal to, that means the quantity of type A and type B gears consume exactly 1200 minutes of production time in the blanking shop, or we can have quantities x1 and x2 in such a way that the total time taken is not equal to 1200. So let's say, just to understand, x1, that is gear of type A, takes 20 minutes each, and gears of type B take 10 minutes each. However, after producing a certain number of gears of type A and type B, if there are only 5 minutes left, then you can not produce either type A or type B because the minimum time taken by either of the two is 10 minutes. So then this means that the whole of 1200 minutes is not utilized. So in that case, 20x1 plus 10x2 will be less than 1200. So if we add this 5 minutes to this equation in terms of a variable which indicates the unutilized capacity or the time in the blanking shop, then we'll be able to make left hand side equal to the right hand side. So let's say S1 is the slack variable representing the unutilized capacity at the blanking shop. So let's add this variable to this constraint. So our equation becomes 20x1 plus 10x2 plus S1 is equal to 1200. Now, if the quantity of type A and type B can consume the entire production capacity of 1200 minutes in the blanking shop, then the value of S1 will be 0, or in other words, there will be no unutilized capacity. Now, let's say that there is no production happening for gears of type A or type B in the blanking shop. That means X1 and X2 are 0. So then S1 becomes equal to 1200, which means that all the capacity in the blanking shop is now unutilized because there is no production currently happening in the blanking shop. So basically S1 can range between 0 and 1200. So here S1 is greater than or equal to 0. Now this is for the blanking shop. Let's take the case of the gear shop. So for the gear shop, the constraint is 40 times x1 plus 10 times x2 is less than or equal to 1600. This is for the gear shop. Now again, what this constraint means is that the time taken by gears of type A and type B in the gear shop is less than or equal to 1600 minutes per week. So again, as we had seen for the first constraint, there is a possibility of unutilized capacity, which indicates this less than sign. So here let's introduce the slack variable S2. So this is the slack variable which is representing the unutilized capacity at the gear shop. So now let's rewrite the constraint using the slack variable. So 40x1 plus 10x2 plus S2 is equal to 1600. Now again, if there is no unutilized capacity, that means the production of gear type A and type B are taking the entire capacity of the gear shop, then S2 will be equal to 0. However, if there is no production happening and all the capacity at the gear shop is unutilized, that means x1 and x2 are 0, then S2 becomes equal to 1600. So S2 can range between 0 and 1600. Also S2 is greater than or equal to 0. Now next we look at the objective function, which is to maximize P, where P is equal to 10 times x1 plus 4 times x2. Now since we have introduced two slack variables S1 and S2 in the constraints, the simplex method requires that the objective function must contain every variable in the system. So basically we need to add S1 and S2 to this objective function. Now our objective function includes P, which is nothing but the profit. And profit we know is equal to revenue, that means how much value have we sold, minus the cost, that means how much cost have we incurred to manufacture or source that material. Now we have already added the profit gained by selling gears of type A and type B. We had been given that each gear of type A gives a profit of 10 rupees and each gear of type B gives a profit of 4 rupees. So this is equal to the revenue minus the cost. That means the selling price of each gear of type A minus the cost of manufacturing each gear of type A is 10 rupees. Now there can be some unutilized capacity which is represented by S1 and S2. So basically there is some idle time during which there is no production happening. That means there is no revenue generated during that time when there is unutilized capacity. But still there is some cost which is incurred, such as electricity cost or idle labor cost or unused material cost, etc., associated with the unutilized capacity. So we need to consider the cost in terms of slack variables added to the profit equation, because ideally they can contribute to reduction in the profit. However, for our purpose of solving this problem, we will consider the cost of this unused capacity as 0. And this 0 will be expressed as the coefficient of the slack variables. So we will introduce the variables S1 and S2 to this profit equation, but with a coefficient of 0. So our objective function will become P is equal to 10x1 plus 4x2 plus 0s1 plus 0s2. So this is our new objective function. This is our first constraint and this is our second constraint.